Hello, welcome to the first of two videos on special right triangles. In this first video, we're going to be able to look at the 45-45-90 right triangle, find out the side length relationships between the legs and the hypotenuse, and then use those relationships to find missing side lengths within a 45-45-90 right triangle. The first video will deal with 45-45-90, the second video will deal with 30-60-90. When we find missing side lengths, there may be a moment where we have to simplify radicals or rationalize denominators in order to simplify the answers. Those are previous skills taught in the class. So the 45-45-90 right triangle is a half a square. If you cut a square down the diagonal, you get a 45-45-90. And we all know that squares have all sides the same length, the congruent side lengths, which means the two legs of the triangle are also congruent. So we put the tick marks there to let us know that they are congruent. So for example, if I name one leg x, then the other leg has to be x, has to be the exact same. Now, if I wanted to find the hypotenuse, the side length across the 90-degree angle, I'm going from leg to hypotenuse. It turns out you multiply by square root 2. So if my leg is x, I just take x and multiply by square root 2, and that's my hypotenuse. Conversely, if I go backwards from hypotenuse to leg, so working backwards from multiplying by square root 2, we're just going to do the inverse of multiplication and divide by square root 2. So to go from hypotenuse to leg, we're going to divide by square root 2. And we do division because division is the inverse of multiplication. And that's the only side length relationship we have because the two legs are congruent. Doesn't matter which leg you choose to go from leg to hypotenuse because they're both exactly the same all the time. So we have two examples down here of a 45-45-90 right triangle in each and missing side lengths. Now a triangle that has three sides. In each example I'm going to give you a triangle with one side given and you have to find the other two sides. Contrast this with a Pythagorean theorem problem where you're given two side lengths and you have to find the third. So I'm going to give you less information for these triangles and ask for more information in return because we know the side length relationships detailed up here. And it all starts with identifying what's given to you and then what do you need to find. So in this first example, they give you 3 root 2 over 2, one side length, and they ask for x and y for you to find both of those. Well, 3 root 2 over 2 is a leg. Y is a leg. And x is the hypotenuse. So you are in charge of finding one leg and one hypotenuse. Let's start off with the simpler variable to find. Y, the leg, is easy to find because every 45-45-90, I can put the tick marks here, because they are always congruent. The legs are always congruent. So if that's 3 root 2 over 2, then y is going to be also 3 root 2 over 2. Really no work necessary. Just write down the relationship, or know the relationship between the two legs, and you can write down the side length there. Now, on to the more complicated, in quotation marks, relationship. If I'm going from leg to hypotenuse, in case you forgot, you can scroll back up here, or look into your notes. Leg to hypotenuse, we look up here. That arrow from leg to hypotenuse shows that I should multiply by square root 2. So I'm going to write that down here. And I encourage you to do this within a problem as well because it helps you frame what you're going to do to that number. It may look more complicated than it is because it's a fraction with a radical. It doesn't change depending on the way the number looks. You're still going to multiply by square root 2 all the time if you're going from leg to hypotenuse. So let's do the work over here on the right side. 3 root 2 over 2. And you're going to multiply that by square root 2. Now, the second number, square root 2, is a fraction over 1, We just don't write it because you divide things by 1. It doesn't change the number, so therefore it's unnecessary to write. And when you are multiplying fractions, it's numerator times numerator, denominator times denominator. So on the denominator side, 2 times 1 is 2. It's pretty straightforward. 2 times 1 is 2 on the bottom. On the top, when you multiply radicals together, or numbers with radicals together, there's a rule you have to follow. Numbers inside the radical can only multiply together, and numbers outside the radical can only multiply together, but they can't mix. The only way a number comes outside the radical is if you square root it. So in this case, I have 3, which is outside, and nothing multiplies with it, so it's going to stay 3. Then I have root 2 times root 2. I'm going to highlight that so I can show you the relationship here. Root 2 times root 2. So I can multiply those two numbers on the inside together. 2 times 2 is 4. So this is going to turn into square root of 4. I'm going to highlight it so it shows you the exact same number. So square root 2 times square root 2 is square root 4. That becomes 2. The square root of 4 is equal to 2. So I'm going to keep the highlighting there so you can see that it's the same number throughout. Now from here, we've been taught that 2 divided by 2, right here, that's 1. So when you multiply 3 by 1, 3 doesn't change anything. It's just still 3. So therefore, when we see 1 in a fraction, we cross it out, telling ourselves we don't have to write it anymore. So this hypotenuse ends up just being 3. So to recap, we were given a leg. We immediately found the other leg because they're always congruent in a 45, 45, 90. And then to find the hypotenuse, we multiply the leg by the square root of 2. Moving on to our next example. In this example, they give you 4, and they're asking for x and y. 4 is the hypotenuse. It is a cross from the 90-degree angle, in case you didn't know. X and y are your legs. And again, in a 45, 45, 90, the legs are always congruent. If I'm going from hypotenuse to leg, let's go back up to our diagram here. Hypotenuse to leg. We'll zoom in on that. It says I'm going to divide by square root 2. And that's exactly what I'm going to do here in this example. And I'm going to write it out to remind myself that I am doing it. Divide by square root 2. Some of the struggles that students have about these problems is remembering what number to multiply by or divide by. It helps you write it out every problem. It takes a little bit longer in the beginning, but once you get used to it, you'll start predicting what you're going to do before you write it down and therefore committing it to memory. So it takes more work in the beginning, but it pays off in the end in helping you find missing side lengths here. So we're going to divide by square root 2.